Hello and welcome to STAAD.Pro training courses. Today we will see how to specify an advanced buckling analysis. This session consists of 3 parts, and we will start with defining the buckling analysis objective. Buckling is a very dangerous condition. The failure occurs suddenly as a structural collapse with little or no warning. Buckling analysis helps to check if the structure is stable under certain loading conditions. The buckling load factor is the main result that we're looking for when performing buckling analysis. Let's have a closer look at buckling analysis implementation in STAAD.Pro. STAAD.Pro offers 2 analysis methods, basic and advanced, both based on linear buckling analysis using linear elastic small displacement theory. The buckling load factor reported by both methods is the global Euler buckling. Buckling will be performed only for primary load cases. Combine loads using repeat load command. STAAD.Pro includes automatically the effects of geometric stiffness except for solids and curved beams. The advanced solver requires a STAAD.Pro advanced license. It is important to remember the difference between load combinations and primary loads. In this example, in a fully linear analysis, both cases will lead to the same results by virtue of the principle of superposition. In a buckling analysis, superimposition principle does not apply. The buckling factors will be calculated correctly only if we analyze the case where the 2 loads are acting concurrently. And only primary loads are analyzed. Combinations are just a combination of results from the individual loads. Therefore, traditional load combination should be used in a linear elastic analysis only. In a buckling analysis, one would need to create new primary loads that combine basic primary loads. This is made easier using the repeat load command. The advanced buckling analysis procedure is an eigenvalue calculation to get buckling factors and buckling shapes. Perform buckling agent command directs the program to perform the analysis that includes the following steps. First, the primary deflections are calculated by linear elastic analysis based on the provided external loading. The second step is primary deflections to be used to calculate member axial forces and plate central membrane stresses. These forces and stresses are used to calculate geometric stiffness terms. Both the large delta effects and the small delta effects for members are calculated. These terms are the terms of the geometric stiffness Kg matrix. Next, an eigenvalue problem is formed. The user has main 2 control options. Iterative method is a basic option. Results are based on the highest successful buckling factor estimate that was calculated. Agent method is an advanced option, solving an eigenvalue problem for up to 4 buckling factors and buckling shapes. There are a few notes about advanced buckling analysis in STAAD.Pro. Solid elements do not contribute to stiffness matrix in STAAD. Buckling shapes for the last buckling case only may be displayed in the post-processor. If there are several buckling cases, then all will have their buckling factors printed. The displacement and member element results are not calculated for the load case times the buckling factor. If the loads must be in the opposite direction, STAAD.Pro will calculate negative buckling factors. After the analysis runs successfully, the results will be available in the post-processing. Go to Layouts, select Buckling on Dynamics ribbon area. By default, there will be up to 4 buckling factors and related buckling mode shapes. Buckling factor less than 1 means that the load causes buckling. Greater than 1 means buckling has not occurred. If it is negative, then the static loads are in the opposite direction of the buckling load. Also, the buckling analysis results are available in the output file. Let's see the application example models in STAAD.Pro. The first model is steel frame We've already assigned section properties, specifications, and support conditions. Let's prepare our model for advanced buckling analysis. Go to loading page, load cases details, and let's review the two load cases already existing in this model. And let's create the primary load case number 3 for combining two existing load cases. Use repeat load to combine the loads. Next, go to the analysis page, define commands, perform buckling analysis tab, and select the radio button near the agent method, press add, and let's go and run analysis. After the successful analysis, let's go to the post-processing and review the results. Go to Dynamics, Layouts, Buckling, and review the results. Buckling factor is 1.2, which means that the structure is stable under the existing loading. Also, the results are available in the output file. Select Agent Solution and review the buckling factors. The second model is finite element model of the steel beam, and we will issue the commands to perform buckling analysis. On the loading page, we can see that two primary load cases already exist in the model, and the third load case is a combination of the first two load cases, and we will combine them with repeat load command. Go to analysis page and issue the perform buckling agent command and run the analysis. After successful run of analysis, let's go and review results in the post-processing. In this case, the buckling factor of 13 was achieved, which means that this beam is stable under the applied loading. Thank you for watching.